So, hallo. Heute mal als Form des Livestreams eine Serie über Bücher, a series about quantum mechanics or books about quantum mechanics. I have some German volumes, some English volumes here. I start with the first book. This is from Franz Schwabl. So this is professor of the University of Munich. I think he died a couple of years ago. It's an excellent book. I worked quite a lot on it, and it contains all the typical topics in quantum mechanics. So it starts with wave functions and one-dimensional problems, one-dimensional oscillator, angular momentum, central potential problems, spin, and so on. Perturbation theory, also some perturbation methods like WKB. This is not so well known. Realistic corrections, some electron models with one and a couple of atoms with one and a couple of free electrons. Zeeman effect, molecule stuck effect. Time-dependent quantum theory, time-dependent perturbation theory, scattering theory, and there's also a short chapter about supersymmetry. Included in the last chapter is about the measurement process in quantum mechanics. So that's a nice book. And there is also a second volume available. This is a volume on many body theory, many body perturbation, quantum mechanics theory. 1 second. So that was the dog that came to our house during the last 2 years, which cannot wait to get food. So a very nice book. I can really recommend it for German readers. Second volume I have here is from my home university from Darmstadt. It's Professor Eugen Fick. Einführung in die Grundlagen der Quantenmechanik. It's from my home university from Darmstadt. It's Professor Eugen Fick. Einführung in die Grundlagen der Quantenmechanik. So, Introduction into the Foundations of Quantum Mechanics, 6th edition. I think it's not well known. It's a very nice and concise introduction, but it's not so. The structure is quite different from what you will get in your typical lecture. But it starts also with some chapters on and classical mechanics basically, and also on Planck, on the Planck theory of radiation, and it really slowly develops the wave function from this one, but it covers really a lot of topics. I haven't read the whole book because it's quite, from a style, it's not so typical. It's not matching the usual lecture. So, but it covers all the Schrödinger equation topics, and then there's an introduction to vector theory of quantum mechanics, Brown-Ket notation, scattering theory, and also some statistical physics. Here. It also covers many particle systems, and it covers the quantization of the Schrödinger field, the Bose field, the Fermi field. The notation is somehow at some point a little bit odd. It also covers scattering processes, because sometimes you use very odd science, either in, let's say, like a script, so it's not so well readable. But that was actually my first book on quantum mechanics. I bought it when I was in grade 12 or so, and I didn't understand anything. One book I already presented is Modern Quantum Mechanics from J.J. Sakurai. And I can really recommend this book. This is a fantastic book on quantum mechanics, and you can really learn quantum mechanics from it. The first pages are really eye-opening. The first page is about the introduction to the prime ket notation, and it's really, really worthwhile reading this book. Okay, so now the dog is inside. We can continue. The next book is really really classics, and this is the 4th edition of Paul Dirac's Quantum Mechanics. I mean, this is a very old book, of course. I think this book is from the 4th edition. I think it's from 1974 or so, from 1967, but the print is from 1974. And this covers basically all the topics of quantum mechanics. So representation, harmonic oscillator, angular momentum, perturbation theory, scattering theory, many particle theory of radiation, also relativistic and relativistic quantum theory, and even quantum electrodynamics. But the last 2 chapters are, of course, outdated and are not complete from the today's standpoint of quantum mechanics or quantum field theory. But the first chapters are, I mean, they are really written with a unique style. It's comparable to maybe the Landau-Lifshitz books, which I discussed in a previous video. So it's really a beautiful book, and maybe it's not the book to learn stuff from, but it's really a nice book to have and to browse through. I think the most modern introduction I have is lecture notes on quantum mechanics from Steven Weinberg. And I love the books of Steven Weinberg. I have the quantum field theory books. I have the general relativity book, and a couple of other books from him. And he's really a master of teaching. It starts with a historical introduction, then particles in the central potential, then general principles of quantum mechanics, symmetries, time translation, stuff like this. Then it covers spin and rotations, angular momentum, approximation for methods like first order perturbation theory, variational method, Born-Oppenheimer approximation, WKB approximation, and so on. Approximation for time-dependent problems, and scattering theory. Also nice topics like Berry phase is discussed. Then general scattering theory, like S-matrix theory, and stuff like this, optical theorem. Then it covers canonical formalism from Lagrange and Hamilton, formation derived, charged particles, and quantum theory of radiation. And the last chapter is dealing with entanglement, so it's dealing with the measurement process. It's like a 350-page volume, and it's really a nice and unique introduction. Also not the volume you're reading beside the lecture, but it's really, really a nice book. and really worth reading it, maybe reading it chapter-wise after you studied the whole subject. And it's also called Lectures on Quantum Mechanics, so it's derived. Next one is also not a classical textbook. It's also a little bit unique. It's also available in English, of course. It's from von Neumann, Mathematical Foundations of Quantum Mechanics. And this is also very nice. But it covers basically the mathematical prerequisites of quantum mechanics. I mean, in chapter 2, it's introducing Hilbert spaces, and chapter 3 is about quantum statistics, and then the chapter 4 is maybe the most important chapter, which is a very precise and deductive derivation of quantum theory from a couple of basic principles. And these principles are called, I think they're also called von Neumann principles. And the last chapter is about the measurement process. So this is also a nice complementary book on quantum mechanics. Not the books that you read as a beginner on quantum mechanics. And it really has a focus on the mathematical aspects. If you want to dive deeper in the mathematical aspects of quantum theory, then I can recommend 2 books. I think one I have recommended, or I've shown you already. So this is from Walter Thierring. I think it's the 2nd volume about quantum theory and quantum field theory, or quantum electrodynamics. And another book is about it's this one here. It's a surprise introduction now. It's from Weidmann, lineare Operatoren in Hilberträumen, so linear operators in Hilbert spaces. But this is also purely mathematical, which covers the background of quantum theory. And this is also 2 volumes, so there's a 2nd volume, of course. And I think this one is only available in German. So the last 2 books I want to present, I think this I keep for the end. The next book is from Nobel laureate and Bernard Diou and Frank Lalleux, if I pronounce it correctly. It's a French theoretical physicist. And this book is starting with so from the theoretical point of view, but like 170 pages, you also come to Bra and Ket vectors and operators, Bra and Ket vectors and operators. It's written in a way that you have a chapter, like the first one is on particles and waves, and the second, and then they have some additions to this chapter. So you can read basically the first pages, and then you have an addendum of about 40 pages. And it's written in the whole style is like this. So chapter 2 is on mathematical foundations, and chapter 3 is on the basic foundations of it. You have an introduction of spin and 2 level systems and stuff like this. A harmonical oscillator, angular momentum, and so on. In the second book, basically then central potential problems and hydrogen atom, of course, basic scattering theory, spin, angular momentum addition, perturbation theory, and approximation methods, and scattering theory. And also this last chapter is on identical particles, so it's kind of a little bit on statistics. The main critic about this book is that it's altogether it's like 1400 pages. So this is basically, I mean, the level of introduction here, this is maybe the easiest book on quantum mechanics you can get, these 2 volumes. But it's really a lot to read. It covers this in a 1 or 2 year course, and I think you will not be able to read a 2 year course, these 2 books in 2 semesters. Yeah, that's quite impossible. But if you want to reread a couple of chapters, let's say in parallel to the lecture, I can really maybe recommend the first volume, and don't try to read the whole volume, but try to read chapter wise by interest. So we are coming now to the last books, and this is also 2 volumes by Albert Messiaen. And I think he is the PhD instructor of Cohen-Tannoudji or something like that. And this is a total classic. This is also available in German and English. So it starts with in German and English. So it starts with the old formulation of quantum theory, so also with discussion of Planck radiation formula, Schrödinger's wave equation, and so on, interpretation of the wave equation, classical approximation methods like WKB. Then it goes to a more modern introduction. The second part of the first book is then about simple systems. So central potential, solution, hydrogen atom, of course, then scattering problems and scattering phases, Coulomb interaction, and of course the harmonic oscillator. The second part is about angular momentum and perturbation theory, and also time-dependent perturbation theory, variational methods, and scattering theory. And there's also a small two chapters about relativistic quantum mechanics and quantization of the electrical field. But of course, the last 2 chapters, you better get a book about quantum field theory, and skip it here. But it's a very, very complete book. It covers so much material, and I can remember that I had to use some weird symbols in my diploma thesis, and I think it was the Wigner 9J symbols in they're connected. They're coming up in the edition of angular momentums, and I actually found here a decomposition of the Wigner 9J symbols into, I think, Clebsch-Gordon coefficients or something like that. And then I was able to program it with Mathematica. So it's really a helpful book for me. it saved me a lot of time in my PhD thesis. But in my diploma thesis, by the way, I might calculate some angular momentum correlation coefficients, and this was quite a complicated stuff. And in the program we used to calculate these. Was an ancient program written in some Fortran code from the 70s. So I rewrote it in Mathematica at that point, and I tested it, and I really got the same results. But it's I think it filled 2 pages in my diploma thesis only with a very, very long formulas in order to derive these Clebsch-Gordon coefficients, or in order to declutter these Wigner 9J symbols into Clebsch-Gordon coefficients. So this is a very, very nice book. I can also recommend it besides a lecture even. It's you maybe have to skip the first chapters or read it very quickly and start with chapter 2, because this is usually the point where your quantum mechanics course will start. And it's a very nice introduction to quantum mechanics, and it's like the major reference here. It's really I mean, if you want to have a encyclopedia about quantum mechanics in your bookshelf, buy this one. Also available in English and German. Of other great books about quantum mechanics, I presented a couple of them in my earlier series. There's a book from there are at least 2 books from, or 3 books from Greiner about elementary quantum mechanics. There's a book of Nolting, and also an easier one from Fliesbach, shorter one from Fliesbach about quantum mechanics, which I think I don't have. And one edition, the Sakurai book is fantastic, but there's also a second edition, or not a second edition. There's now, I think, a 4th edition of this book here. So if you get the very new one, it's from Sakurai and Napolitano or something like that, an Italian guy. And this I also can recommend. It's a very nice one, but I don't have it, the 4th edition of this one. But there is also a second part here, Advanced Quantum Mechanics. And this is not it's written in a very old-fashioned style. So it's using the ICT notation for in special relativity and stuff like this, stuff you don't do today anymore. So don't get advanced quantum mechanics from Sakurai. Only get modern quantum mechanics from Sakurai. Maybe in the most recent edition, I think it's a 3rd or 4th edition. This is the revised edition, so of the 1st edition. I mean, Sakurai died during the writing of this book, and it was finished by his friend San Futuan. And you somehow recognize that after 4 chapters or so, the spirit changes a little bit. I think they had the notes of Sakurai available. Died in 82, so 42 years ago. But they didn't actually manage to explain things in a way that Sakurai did. So after chapter 4, and chapter 4 is about angular momentum, the book somehow declines a little bit, but it's still a great book. It's still a great book, and it's really worth reading it. So my favorite book my favorite book, together with a lecture, and my favorite encyclopedia. So that's all for today about quantum mechanics. And I think the next series will be somehow about general relativity or so. And hopefully it doesn't take 2 years to complete it. Okay, have a good day. See you. Goodbye.